Hello, Rick. This is Sarah Court, and for assignment number 2, I'm exploring Canada's renewable energy sources, both generated and consumed, with climate change having such a significant impact on the world. I wanted to look a little closer at Canada to gain some insight on how we've changed our methods of producing and consuming energy over time, and if we are reducing the generation and consumption of fossil fuels and non-renewable energy sources. I want to see if Canada is making a positive impact towards reducing climate change for our country and the world's future. To gain this insight on the topic of renewable energy in Canada for assignment number 2, I have collected data regarding the generation, the importing, and exporting of both renewable and non-renewable energy sources. And you'll see that these data sets are dated from 1985 to 2021. This data is comprised of 3 data sets, separate data sets, and the combination of raw data between the 3 sets contains over 100,000 records. And with my analysis, my primary objective, like I mentioned before, is to find trends and patterns over time, because I want to know if Canada is changing the bad habits of producing and consuming fossil fuels and non-renewable energy. So I want to get a bigger picture of what steps Canada is taking to create a more sustainable future for our country. You'll see throughout my demonstration, I'm using Microsoft Excel, Jupyter Notebook, and Tableau, and my video from here on out will showcase how I've used the techniques learned in class to clean and transform data, manipulate the data, describe and analyze the data, and create effective data visualizations. So we'll get started. These are the 3 raw data sets. So I've got imports and exports of non-renewable energy resources. I have 2 different data sets on power and electricity generation. This first one here just shows you the source, and this data set here has got a little bit more information. This one here shows you the class as well as the type of electricity generation. I'll show you the clean data sets here now. So I've spaced the imports and exports out a little bit to fit the width of certain values in the columns. This is the one that dates back to 1985, as you can see here. I wanted to compare Canada's GDP from these time periods, but it wasn't necessarily related to the topic, but it definitely sparked a little bit of curiosity in me. This data set also shows you where the import came from, or where the export started, and it includes other countries, not just Canada. It shows you the port, the value. Most of the monetary or currency values were not included, but I kept all of the NAs just because even in those columns there was still so much data that could have been useful for this analysis, and deleting any records with all these NAs would have skewed the data set. So looking here is my first pivot table and chart. I'm looking at all of the years, 1985 to 2018, and I've decided to filter by activity. Now, there was various categories of types of exports and imports. However, they all sat slightly above 0. So I decided to filter those out and just focus on the number of exports and imports of these non-renewable resources. And you'll see my legend at the top shows you that exports are the line at the bottom, imports are the lighter green. Obviously, this shows that we import more of them were unknown. Like this one, I split up the month and the year. Whereas for this one here, there wasn't a lot that I needed to change. And we have no measurement for the amount of solar that was generated. Looking at my pivot table, I've filtered by source, but I took out solar because they were all 0. And I've included all of the values available. Now for the third pivot table and chart, you'll see I've filtered by location, only including the totals for all of Canada. For the type of electricity generation, again, I've only selected the total of all types since it includes all of the other selections. You'll see I have my years. I've removed 2021. Looking here, you'll see I added a trend line to this chart as well, showing an increase of power being generated. I've put a call out showing that in 2008, there were 1.2 gigawatt hours generated. And going forward from 2015 to the second half of the decade, you'll see now we're sitting at 1.27 gigawatt hours of power generated. It kind of goes with what the import and export data was showing us, that there has been an increase of generation regardless of whether it's being imported to use and consume in Canada or whether it's being exported. But I guess this one here does include renewable sources as well as non-renewable, whereas the import and export chart was only showing non-renewable resources, which obviously plays a factor because we're consuming and producing more renewable resources as well as, you know, the fossil fuels and non-renewables that we're already producing and consuming. Still follows the same kind of trend that the other chart was showing us. And now we'll go take a look at Jupyter Notebook and show you how I cleaned up some of the data there as well and what I've done to describe and analyze and visualize the data in Jupyter Notebook. So we're in Jupyter Notebook. You can see I've loaded and started SQLite, so I can commence coding. I've imported all my libraries, and so I started by displaying max rows so that when I imported my data set to make my data frame, it would display all of the rows. Now I decided to only use one of my data sets for Jupyter Notebook purposes. It would have really slowed my computer down. I decided to work with this one, and then when I go to Tableau, I've visualized all 3 of the data sets, but this one is just focusing on the electricity generation data set. So this is my raw data. That way I could demonstrate the cleaning and the manipulation of the data here in Jupyter Notebook. You'll see that I also added a column X filled with blanks and NaN values. So first things first is I dropped that column X. You see the difference here. And then I rearranged the columns. So I've got my year over on the side, and the region, your source, and the amount generated. Now I decided to change the name of the column, amount generated. I renamed it to gigawatt hours. And it looks a little neater, nicer. And I added a calculated column. Here, like if you look in the region, it's all the provincial codes. I changed all those abbreviations to the full province or territory name. Now, to grab the shape of the data, it is 1,344 rows and 5 columns, counting the non-nan values in each column, and after removing column X that was full of blanks, there's none. To grab the summary of statistics using the describe function, describes both the gigawatt hour and megawatt hour columns, and count, mean, and the max gigawatt hours from the data set is almost 39,000 gigawatt hours, and the minimum is 0, obviously. You got your mean at just over 11,000 gigawatt hours. Now to display columns by head and tail. So here I've called where the region is Canada and the source is solar. Obviously there's one solar value. Interesting. Like you think it would pull up the solar value for each of the years, but it doesn't. Now looking at the tail, I have called the year 2007 where the gigawatt hours is over 0. It gave me 2007 to start my tail 10, but the years are, ascending afterwards. Here I'm using the group by function. I'm grouping by size, and then second one I'm grouping by sum, and using source. See, they all have 168 values. And the second group for the sum, it shows you the group with the gigawatt and megawatt hours. According to this, which is consistent with my analysis in the pivot tables and charts, that hydro is the most used method or source of producing power and electricity. And here I'm using group by with the region. So you can see the mean gigawatt hours for Canada as a whole is over 77,000 gigawatt hours. Looking at the provinces and territories individually, none of it is the lowest. We have 17.9. We've got Northwest Territories at 74.5. PEI surprised me because them being, surrounded by water, you think they would have like a high amount of power produced by the hydro and tidal turbines. Set my index to the year. I've used lock to call the year 2007, the random year. You see it actually brings up all of the 2007 values because it's not just one value. It generates a little table of the values that are listed for each record that has 2007 listed as its year. And now using iLock, I've called up record 777. That brought up Nova Scotia. Wind for the source, 110 gigawatt hours or 110,000 megawatt hours. And before I prepared for creating my visualizations, I have removed all the rows that were listed for Canada. I wanted to remove the totals so that I could visualize the differences between each province or territory. And here I reset my index. So here I have electricity generated by region. I'm looking at each of the provinces in alphabetical order. And the value in gigawatt hours of electricity generated. And you'll see that Quebec has generated the most, with us in Ontario falling slightly under them, but both Quebec and Ontario are significantly higher than the other provinces or territories. I created electricity generated by year. As the other visuals in the pivot charts had demonstrated, there is an increasing trend of electricity and power being generated as the years go on. So this indicates to me that Canada is not necessarily taking the right steps. So now we'll move over to Tableau. You can see I have imported all three of the data sets. So I've created quite a number of visuals to help me get my insight that I was looking for so that I could make a conclusion. I started by using the import and export data set. I split up imports into 2 different time periods, and then I did the same for exports. Now, just to quickly recap the 1985 to 2000 timeline. See that within that 15-year period, butane was the most imported. Propane and butane were the most exported. I've made maps for each of the types. This is your wind turbines. You've got Ontario and Quebec using the most wind turbines. This is my solar map. Quite alarming that Ontario is the only region in Canada producing solar power. Here we've got steam turbines. Alberta uses the most steam, which actually doesn't surprise me. Now looking at tidal, this makes obvious sense. They're the only places in our country that have access to even get power in that form, because they use turbines associated with the extreme force of water. Like obviously Ontario is the largest user of hydro to produce, hydroelectricity. However, the force and kinetic energy produced by our lakes, even the Great Lakes, they don't compare to the oceans. Little Nova Scotia, they're at 427.9. Nova Scotia is the only province in Canada using tidal power to generate power or electricity. We've got combustion. Alberta, they're sitting at over 190,000. Ontario, 128. BC, 26. It's quite the difference. Hydraulic. Ontario is under 1 million. Quebec's over 5 million. And nothing compares to the amount that Quebec is producing with hydraulic turbines. I've included the map that focuses on power generated by all types of sources. So Quebec produces the most power. I've included the types of electricity produced in Canada, combustible fuels being the highest number of gigawatt hours produced. Non-renewable combustible fuels sit behind that. Biomass sitting at the lowest amount of gigawatt hours produced. And I've included imports and exports of energy resources. This shows 2000 to 2018. Butane and propane as the highest imported and exported. So I've included this dashboard in my presentation as well. Over the past decade, even after the carbon tax was implemented in 2007, the total amount of power generated has increased significantly and consistently each year. We produce 0.14 gigawatt hours, or roughly 140 million watts per year. That can power up to 140,000 homes per year. Although the number of energy resources imported consistently sits significantly higher than the number of exports, Both numbers have followed a similar increasing trend over time. With imports consistently at a higher number than exports, this indicates that Canada is using more energy than we produce. Imports and exports of fossil fuel resources have both been increasing over time, indicating that Canada is producing and consuming more non-renewable energy sources each year. Canada is in fact not taking the necessary steps they can be to reduce the impact of climate change.